You run git clone, hit enter, and there it is, a massive, undocumented beast of a repository staring back at you. You didn't write it, you don't know the conventions, it's just intimidating, right? Well, today on The Explainer, we're going to completely dismantle that creeping dread of unknown code bases.
It's a completely universal anxiety for developers, honestly. You open a repo and ask yourself, where do I even begin? It kind of feels like walking into a chaotic crime scene where you don't even know who the victim is yet. But treating it like a crime scene, that's actually the perfect mindset. You don't need to know the history of the entire city to solve the case. You just need to secure the room, look for clues, and follow the evidence.
Nobody starts with intuition about a codebase. Seriously, let that sink in for a second. When you see a senior dev jump into an unknown system and just intuitively fix a bug in 20 minutes, that isn't magic. It's just a highly refined, repeatable process. They aren't memorizing the whole system. They're just practicing extreme discipline about where to look, in what order, and exactly how much they actually need to understand before touching a single line of code.
So here's our roadmap. We're going to hit the myth of intuition, investigate the issue, trace and understand it, make the minimal fix, test and verify, and finally wrap it up with the universal debugging process. And to prove this framework actually works, we'll trace a real-world bug in a Rust and Tari desktop app.
Okay, let's dive into this. Part 1. The myth of intuition.
The absolute biggest mistake you can make is thinking you need to understand the whole system first. You don't. You just start with a specific problem. Here's our crime scene. We've got a function in our Rust and Towery app called match vendor. Its job is to identify a vendor, like a payment processor or some SaaS tool, from a URL. But it's failing. Why? Well, it's matching keyword strings against the entire URL string, including the path and query parameters, instead of just isolating the host. That right there is everything. Before even opening a single file, we already know this is a scoping problem. It's not some grand, complex logic puzzle.
Moving on to part 2. Investigate the issue.
When that bug report comes in, how do you handle it without just getting completely overwhelmed? First thing, take a breath. Step 1 is to read the issue slowly. Like, read it more than once. The issue ticket is literally the only artifact telling you what the maintainer actually believes is wrong. Look for specific inputs, expected behaviors, linked function names. Step 2 is finding the entry function. For us, that was match vendor. If you don't have a specific function name, just search for the user-facing error message or button label. grep is your absolute best friend here. It is way more useful in the first 10 minutes than desperately clicking through a maze of folder structures.
Now, the novice instinct is skimming the bug report, jumping straight into the IDE, and poking around blindly. You've got to resist that urge. The veteran approach is reading carefully to actively narrow the search space. By reading closely, we turn a vague, hey, debug this URL thing, into verify and fix this one specific scoping issue. Believe me, that shift in mindset saves you hours of wandering in the dark.
All right, part 3. Trace and understand.
Now that we've secured our entry point, we follow the thread. Ask yourself, what calls this function and what does this function call? In our Rust app, a caller passed in a full URL string, and the function just ran keyword matching against it. That was the whole shebang, no hidden middleware. Once you know that data flow, step 2 is crucial. Understand the existing helpers. Does the project already have a URL parsing utility? Some logging convention? Reusing what's already there is exactly what separates a clean, native-looking fix from a sloppy one that looks like it was just airdropped in from another code base.
A lot of developers overcorrect here, for sure. They see an unfamiliar function and try to read every single file it touches, every struct, every trait. They try to build this massive, complete mental model of the system. Seriously, don't do that. Your job is to build a narrow, bug-shaped model of just the relevant parts. The real superpower you're developing here is learning exactly when to stop looking.
Which brings us to part 4, the minimal fix.
We've investigated, we've traced, now we execute. Step 1, change the smallest thing that could possibly fix the bug. That's it. That is your only goal. Your mission here isn't to redesign the repository or clean up 5 years of tech debt while you happen to be in the file. Mixing concerns just makes your fix harder to review and a nightmare to revert if you mess up. Just close the gap between the expected and actual behavior with the absolute minimum footprint.
And this brilliantly illustrates the point. A lot of Rush developers would hand-roll string splits on the raw URL, trying to manually hack apart the protocol and the slashes. But remember how we checked for existing helpers? Our project already depended on the standard URL create. So our minimal idiomatic fix is beautifully simple. We just use URL parse, extract the .host string, and match our vendor keywords against that. It's a tiny diff. It leverages the tools already in the project, and it completely avoids writing fragile custom string parsing logic.
Almost at the finish line. Part 5. Test and verify. So you've written the fix, and hey, it compiles. Awesome. But stop right there before you push that PR. A fix without a test is literally just a bug waiting to happen again, silently. First, write test cases that specifically exercise the exact scenario from the issue. But don't stop there. Go a little further. Step 2 is non-negotiable. Run all the tests in the suite, not just the ones you wrote. A fix that looks perfectly correct in isolation might break something completely unrelated if that function gets used outside the call chain you traced. The full test suite is your safety net against those blind spots.
Now, what's really interesting about this slide is how writing tests exposes the unknown. Look at these edge cases we threw at our match vendor fix. We tested a keyword in the path to make sure our host isolation actually worked. We tested URLs missing the protocol prefixes. We even tested inconsistent casing. By forcing ourselves to write these edge case tests, we actually discovered adjacent bugs. We found vendors with mismatch capitalization in the source strings that weren't even mentioned in the original issue. Good test writing uncovers things you would have otherwise shipped totally blind.
Finally, Part 6. The universal debugging process.
We've just navigated a very specific Rust bug, but honestly, the specifics don't actually matter. You need a narrow, disciplined path from symptom to root cause to minimal fix. So the crucial point is this: the shape of this process is absolutely identical, whether you're fixing a one-line CSS typo or tracing some nightmare race condition through an asynchronous event system. Read carefully, find the thread, follow it only as far as it goes, respect the existing code, change as little as humanly possible, prove it with tests, and check that you haven't broken the rest of the world. It's not magic, it's simply a habit of verification.
Which leaves us here. Look, the fear of an unknown codebase is totally natural, but it is entirely conquerable. You don't need a broad, sweeping understanding of a system before you act. You just need your playbook. So, think back to that creeping dread we talked about at the very beginning. With this structured process in your back pocket, I've got to ask, what will you fix the next time you open a massive repository you didn't write? I hope you feel ready to dive in. Catch you next time.